Thank you, David. And the one thing that I've learned in 3 years in government is that I have to be flexible and I have to do what the people above me tell me to do. So therefore, I've become very compliant. So my charge today was to essentially discuss the question of variability in food composition and the challenges that we do face. And where's the slide? Okay. Which one is it? So for many of you, you probably already know that the USDA ARS Beltsville Human Nutrition Research Center has really been charged to help understand the U.S. food supply, both from the terms of food composition as well as intake. And in addition, our scientists collaborate to expand the understanding of food availability, access, food components on effects of food components on health parameters, and really what might constitute what we say is a, quotes, healthy plate. And some of this information is used to help in the development of food policy, namely issues like dietary guidelines, a school lunch program, et cetera. And one of the things that we do have to, and I think to make it clear, is that the USDA has actually held the responsibility of monitoring food composition for over 100 years. And this really started with Atwater and his food composition tables that you see there. But in addition, the USDA BHNRC at the present time is also responsible for monitoring America's, quotes, nutritional health. And this is done largely through the Food Surveys Research Group, where they conduct the dietary surveys for the U.S. population, which is part of the NHANES. And so FNDDS is part of the USDA database systems that I'll be talking about shortly. So I only gave myself 15 minutes to share all of this with you. So I'm going to give this next disclaimer, is that the screenshots that I'm going to show you over the next few slides is that of what we're going to launch in the Q2 of 2019, we hope, which is called Food Data Central, which is a, quotes, modernization of our USDA food composition data systems. And so therefore, all the data, views, and features that are still being finalized and are subject to change before the actual release. So I actually just have screenshots. Now, how's that for really good government disclaimer, right? So on this next slide is really what our homepage will look like. And it essentially says that it has obviously a new look. But the intent of the new FDC, or Food Data Central, is try to provide with the greatest amount of transparency what is the source and source of the data that we're presenting to you, as well as to demonstrate as much as possible the variability that exists in the values that once perhaps have been used as just a single value for a nutrient content in a specific food. So this new Food Data Central will actually be what we call, where's the pointer? Is it this one? Where's the red button? Oh, red button, here. Is really trying to, it's going to be a snapshot in time, but is really trying to integrate multiple different data sets that we do have in the USDA, as well as reaching out to other data sets that exist nationally as well as internationally, and including things that ILSI also has on its websites. And so the new Food Data Central will include these data sets here. Foundation Foods, which is going to be a sort of revamped version of Standard Reference that people have used for years. And Standard Reference as of July of 2018, and that release will be known as SR Legacy. Foundation Foods I'll describe a little later as I show you the examples of it, but we also will have Food and Nutrient Database for Dietary Studies, or FNDDS, that some of you have used. We'll also have access to the USDA Global Branded Food Products Database, which is a public-private partnership with ILSI, and Allison is here, can describe, if you have any questions about it, a little more about that. But essentially, the Branded Foods Products Database, as I said, SR Legacy, and an experimental data set that is still in the process of being worked out. But here, what we're hoping is to be able to bring in information that have been generated in research laboratories that may be of benefit for investigators and researchers that wish to access information about food. So on this next slide, I will show you that the search for Food Data Central highlights the various data sets, and in this case it'll be food data types rather than food type, of where you can access information about the various foods. And the number in parentheses essentially will tell you the number of individual foods that are included in these data sets. So as you can see, foundation, we're really starting out with a small number because we have to express information on variability as well as source and time of analysis, etc. Survey, which is FNDDS, has 8,000, roughly 8,000 foods. We're dwarfed by what's in Branded Foods, which is now close to 300,000 different foods. And as many of you probably know, have looked at that, this is really information about food nutrient intake that's taken off the labels and provided by individual manufacturers as well as Label Insight. And as I said, SR Legacy was the last version of standard reference that was released in April of 2018. And the experimental is still to come. And as you can see, what we're hoping to do is that our search engine will allow us to let you filter your search through all of these databases by clicking or unclicking this, as well as be able to search by ingredients, brand owner, and or thinking that this is going to be like an Amazon shopping cart, that you can click what you'd like and go after what you'd want to do. And the rationale for really making this change was the fact that information and data has increased tremendously, and we are challenged by the resources and the time that it takes to keep up with the changing food supply. And so therefore, in order to try to make it such that we can provide you the best information that we have at a specific time, was to try to incorporate the transparency of where the data came from and let you as the user decide what you'd like to use and how you'd like to use it. So one of the big areas, as I said, was to try to enhance the search features. And in doing this, what we're hoping is that depending on what you end up clicking as a filter, you'd be able to figure out how many foods that will come up with your specific desire for. So in this case, just using a search word Pinto, and you'll understand why I got to Pinto on this one, or Kyle did. And that of all the foods that we now have there in this version, if you click Pinto as a search, you find that there's only one food that shows up in Foundation, about 15 in FNDDS, 1,000 plus in Branded, and 14 in SR Legacy here. And this allows for quicker search options for ingredients and brand owners, as well as by breaking up the data types and displaying the number of results, you can basically see how many pages you might have to scroll through. And I think many of us know when we go to search engines, once you get past page 3, you sort of lose interest. So if you want your product to be up there, you hope it'll show up in the first 3 pages, but this hopefully will help the user streamline his or her search. So in order to try to give you an example of what the search might be, in this case, it's a search that I put in from a screenshot for just looking for milk. And in this case, it was milk whole, 3.25% milk fat with added vitamin D. And so the search result comes up with, in this case, 100 grams. The nutrients here are an average of 24 individual items of milk that were purchased. And this is the average nutrient, or in this case, proximate intake. And what you can see is the minimum and maximum range, as well as the median for the result. And what is different from what was available in the past is the fact that you can now click on what we call sources, and you'd be able to tell where all of these 24 samples of milk were obtained, as well as what the individual values were for each of those samples. So one thing to emphasize is the fact that we think that what's important is that one can see the range of the individual compound that you're looking at, or component, what that range is, and decide whether or not the mean that you might want to use is indeed the mean that you'd like to use for your purposes, or what would happen if you use the lowest or the highest, especially if you're doing predictive equations as to the impact that it might have on a health outcome. So in this next slide, I've narrowed down and gone down under sources to look at vitamin D levels. And here we can see we have the sum value of total vitamin D. And in this case, if one scrolled down, you'd get all 24 values of the milks that were obtained in these cities and states. And from the details that you would see is the fact that really vitamin D concentrations in this particular product actually ranged from 0 to 1.4. And so one would say, wow, you know, what can you do and what does that mean, you know, in terms of having such variance in terms of one single nutrient that previously had been reported as a mean. So I think this just emphasizes the fact that we it's very important for us to understand the variability that comes not only from our analytical measurements, but also from the source of the food that we've obtained. So on this next slide, graphically shown are all 24 versions of the samples of milk that we saw. And these are the ones that actually had 0 vitamin D, although the label had said it was 3.25%. And I think the message to take home from this is that there is variability, and then one would have to decide, do you want to use the mean for the purposes that you're using this information for your studies, or do you want to consider whether or not you got something in Tucson versus Kentucky versus New York, and does it make an impact on your patient population and or your, you know, groups of individuals that you're looking at. And I think this transparency of the variation that occurs, we do know that this could be that somebody didn't in this particular batch hit the button that added the vitamin D. So, you know, we would have to, you know, go back and try to understand why that is, but at least you'd know that there can be this magnitude of variation in some of the numbers that you're using, and that may impact what you're then concluding or recommending for consumption for individuals. And again, this puts a lot of the decision making on how to use the numbers back into your hands as an investigator or as a healthcare professional or as a nutritionist. And I think that this does help us in terms of understanding that the variation in our food supply is really much, much greater than we had ever thought it might be. And this, in a sense, may raise the question as to perhaps some of the questions we'd want to address or the gaps we need to fill are not so much knowing exactly what that number should be, but really a bigger question about what constitutes the healthy mix on a plate. So the next thing that obviously people are interested in milk would be calcium. And so here you can see that it's a little tighter. It's between 116 to 130 with a mean of 122. And this difference here, or median here and a mean here. And again, you could go through and we'll have an example, or here the clicks that you would do would tell you the analytical method that was used to determine this calcium value. and then where it was purchased and when it was acquired, because we do know that the food supply changes constantly. So then we go to another food, and in this case, now you'll see why I had pinto, and that this is sort of information that would be obtained from dry pinto beans that was obtained from one of the USDA agricultural sites in both Puerto Rico. In this case, I'll show you both Puerto Rico and Colorado. And again, the information is presented in a similar manner, but you can see now here we have an N of 252, which is a lot larger. So therefore, the mean here and the standard error around this mean with this large an N is probably a lot smaller. But it gives you a sense of what the range would be for protein, namely going from 19 to 30.8. And if you look at calcium, it even goes from 93 to 246. So depending on what the source of your food or your beans are, it could impact really what your intakes are, which may then impact some of the health outcomes that you're interested in trying to relate to a specific nutrient. So this is not to say that this is better, it's just different, but it allows you to, I think, hopefully, recognize that there is a lot of variability that we should take into consideration as we make recommendations and or think about the associations of health outcomes with a specific level of a nutrient intake. No, because branded would be from the label. Right.
So it's just under the foundation.
Under the foundation foods, right. But we have a smaller number of foundation foods now because we really needed to be able to get the information that'll allow us the drill down in terms of where the sources were that we had gotten them from. And so going forward, the hope is that we would begin to analyze foods that would not duplicate necessarily what's available through the branded system, but really perhaps considering ingredients or highly consumed foods that we can go and sample in various different places and show the distribution of the values for that specific food.
So I just want to follow on to Tristan's comment. So what if a manufacturer has like an ingredient, like pinto beans, that you use and you source it specific with certain specs or whatever? Is in the future, is it possible that a manufacturer could submit data for a foundation
Exactly.
food and an ingredient?
Right.
It would not only be
It wouldn't be what we're going
generating
out,
the
right,
data.
right. So what we're working on is actually having a curation group that people can submit their request for being included in foundation foods, and we're automating a means through which we can bring in information from external labs, provided they meet certain criterion that we would set up depending on what the nutrient value, the method that was used to do the analysis, et cetera. So for example, this set of pinto beans actually did come in using this automated approach from laboratories coming directly into Food Data Central. But it happened to be USDA laboratories, so we knew exactly what they had done to analyze. The big difference, however, is the fact that you'd have to see that in this case it's dry weight, so the moisture is 0. So we plan to, improve our presentation of the title here. So it'd be, beans, dry, pinto, and it's 0% moisture. So there isn't confusion about the usual store-bought, which is 10 to 11% moisture. Josh?
Just kind of a related question, I think, underpinning what I might be hearing some concern. Is it possible that any branded food data could come in through the foundation, through somebody else doing analysis? Because where I get concerned, thinking about it from a food manufacturer standpoint is one, somebody does an incomplete analysis so a product would show not having a nutrient that, based off just the fact that they didn't analyze at that time, or somebody pulls something from a shelf that might be expired, and, you know, you would reasonably expect it to still have the label value.
Right.
You know, and so then it shows low,
Right.
where that would be outside of our, you know, manufacturer's direction.
Well,
How's
that's,
that managed?
yeah, well, that will be managed through the group that would be deciding whether or not a specific group wants to submit, say, an analysis of a branded food in there. Because we do recognize that those are issues. And with part of the, which I don't have it because we're not active here, but if you did go down into the details, which was on another page, what you would be able to do is to actually see, in the case of hopefully branded foods, the G10 or G10 code, as well as the expiration date and the lot number. So all of that information would be available under details. So therefore, whoever is using the information will have the data accessible to them. But we're not necessarily opening the doors to everybody wanting to submit foods, because we recognize that, you know, the analytical procedures and methods should be as standardized and as clear as possible, and that we need to present that. So we're trying to build going forward with what we call foundation foods of the future, which really what we're showing here is really the bridge to the future. And from the USDA perspective, much of the interest is also to be able to tie it into production methodologies, cultivars, say if it's a plant source, if it's an animal-based product, where was that animal grown or, you know, harvested or whatever. So it's that kind of thing, and it's really trying to connect agricultural information together with food that's produced as well as food that hits the market. So if we were to go then to the next shot, which is that of pinto beans, what you can see here is the great variability, and if we're just looking at the bottom panel of calcium, and these are all Colorado versus Puerto Rico, because those are the only samples we had at that time, and this is of molybdenum. But what it does show you that for each field and for different cultivars grown at different times, there is variation in terms of what you get. Now, it is perfectly, depending on what your intent of use is, it's quite possible that an average is fine. But if not, then I think what clearly comes across is that location matters. And it's the environmental conditions under which things were grown, as well as the cultivar, as well as the time of harvest, you know, that will impact what nutrient compositions are. And so this is not to say that we can't use what we've been doing in the past, obviously. This is hopefully trying to enhance the availability of information that can help with future modeling as well as future designs of diets. And again, it depends on whether or not you're looking at personalized recommendations or public health recommendations. But I think what really, to me, is very important is the acknowledgement that variation exists, and there are some limitations on the data that we do have. But as long as we know what they are, then we'll be able to, I think, better utilize data in general to be able to come to helpful public health as well as individual conclusions. So I think that, you know, that to me is what the vision of much of this modernization effort was, to try to have greater transparency as to where you're getting these numbers from, and then put it into your laps as investigators as well as healthcare providers, et cetera, and industry, you know, food manufacturers and everything, what you'd like to use and what's best. Did that answer your question, Josh, or?
Yeah, to an extent. So I mean, I understand that it should be able to track it back. The challenge is as it relates to consumers or activist groups taking something at a top line, and, you know, the need to they're very, you know, the press is quick to run with it, and, you know, the results are out there, but, you know, it's very hard to get any information in terms of how they analyze it, what they
Right.
analyzed it, you know, and so I just, really,
That wouldn't be in our database, though, those things
well,
that you're
that-
talking
so,
about.
but-
Right,
understood, but my
Right.
hope is just even with something that if, let's say for the sake of argument, that, you know, there's some information that's up there that would suggest that something doesn't have what's on its label. You know, maybe it was a good analysis, but it just wasn't part of what was analyzed. It sounds to me like that's something that could still be on the database if you, and you'd have to kind of click through to be able to
Right.
defend it.
exactly, right,
So-
right. And the rationale, so the intent is the QA/QC will be done by analysts. And that's after scrutinizing, you know, what the caliber, you know, because it's quite possible that something is not detected because somehow the calibration curve was a little off. So those kinds of notations would be there. And so we're hoping that that would end up being a way that if somebody finds something else that's on the web, you know, on the database, in the database, that you'd be able to call us on it, such that we could do further inquiry as to why that essentially had shown up.
Yeah, I think some things that, you know, might be particularly sensitive right now, just, you know, with some of the current changes, is, you know, things like, I think about added sugars, fiber,
Right.
how people are, you know, how people are measuring that becomes very important.
Right.
Naomi,
Yeah,
can
I
I
think-
just clarify one point?
Uh-huh.
Any branded food product that has a G10 number, a UTC code, there's only two mechanisms. It goes into the branded food products database.
Right.
It wouldn't be in the foundation.
Right.
So therefore, you have the two options through GS1 or Label Insight for the data submission. No
Right.
one can go and say, here's Campbell's tomato soup, and I did analytical analysis of it.
Right.
I'm now gonna put it in the foundation foods. That cannot happen.
That is what I was,
So
Yeah.
the branded food products database does allow you to submit analytical data there, or is it computed? You know, what?
Right. So it's
that
not going,
both-
they're going to be different. And we perhaps have not done the best job of explaining all of that. And since my bosses are saying to move along, I won't talk so much about the launch of that, nor the future, but really to go to what I thought is important is that we'll develop an ontology for the search that can connect various foods and different terms that one uses. Such that if you do go into the database, rather than necessarily clicking on a specific brand or a specific item, that the search engine through an ontology will let you connect back to the source and sort of product development from, say, in this case, the apple. So the questions that I had for you was really, is there really one right number to use for many of the types of studies that we do? And what would be the potential impact of using the highest or lowest on an outcome of interest? And that's something that I think we all have to wrestle with, especially as we talk about dietary guidance. Then what are the sources of variability? And as I mentioned, some of it's environment, some of it's the processing, some of it's how long it's been sitting on the shelf. But really, does all of this magnitude of difference impact the big picture? And does it also impact what we've been defining as shortfall nutrients if there are challenges with respect to how we went around analyzing these and what those numbers mean? And finally, I think what's really important is how do we fit dietary patterns into the picture of assessment and dietary guidance? Because what evidence do we really need? And I think we need new approaches to data analysis that can help us answer those questions and not necessarily the linear thought of boomers. So that's it. Sorry I went over time.